Good morning to everyone and welcome to Department of Aerospace Engineering. This is probably your first class, I am guessing. Okay. So this course that we have here is a course on aeromechanics of unmanned aerial systems. What exactly is aeromechanics? As you are aware, at IIT Kanpur we have started this MTech degree program on unmanned aerial systems, and this is a multidisciplinary program. I gave you some basic introduction, I mean in the Zoom meeting which we had before the class commenced, or I mean at the time when you applied actually here. So just continuing from there, this MTech program has been designed to meet the industry requirements primarily, because in India we are seeing a tremendous growth in unmanned aerial systems technology industry per se, and it is expected that the market in the country in this domain by end of this decade will grow to at least $4 to $5 billion alone, okay, which is a fairly significant market, I mean if you want to say. Yeah. So the idea is to actually build a tailor made program for this, although there are already, I mean we already have traditional engineering disciplines, we have aerospace, mechanical, electrical and so on and so forth, but none of these disciplines does complete justice to this very multidisciplinary domain. Why? Because to build an unmanned aerial vehicle, as we will see, or an unmanned aerial system, we will have to actually bring together so many different technologies, and that is why I mean we allow students from almost every discipline to come and join into this program, whether you are from electrical, mechanical, computer science, civil, even textile. So we have and even normal sciences also, when people from physics background or maths background can also come and join this program. So we assume that I mean you basically are starting from zero, okay, pretty much, okay, and we will try to build a core competency in certain aspects of this, because this is a master's program, not a bachelor's program. So we will not cover everything about everything, we will actually focus about certain key core competencies which will take you to a level where you can join industry and immediately start contributing in building this particular technology and domain in the country. So in this course, aeromechanics of unmanned aerial systems, the key topics we will cover would be related to aeromechanics. So question is, what is aeromechanics? What is your understanding of aeromechanics? Anybody wants to answer that? Have you come across this term before? Before? Never, right? Some of you are from aero background. How many are from aero background? Can you raise your hands? Okay, so only 2 people are from aero background, fine. Okay, and from mechanical? Okay, bunch of people are from mechanical, that's good. Okay. And CS? Okay. 2 people from, you are from EC, right? Yeah. CS, EE and EC? Right, so this is nice, I mean so this is a good mix, I mean this time somehow it is mechanical heavy, so it depends on how it gets, so it's perfectly fine, does not matter, I mean, but yes. So this course and we have very few aerospace engineers, so that way I mean this course is perfect for you to deep dive, but get the whole scope of aerospace engineering in just one course, okay. Which means that I mean in this course I will take you to a point where you will be able to understand and appreciate how any type of unmanned aerial vehicle flies, be it a fixed wing type vehicle or a rotary wing type, so quadcopter, fixed wing drone, flapping wing drones. So we will give you a fairly decent understanding of each of these platforms, okay. And you will be able to reach a point where, so if we go through the course content, I will come to that in a minute, okay. See the fundamentals of, so the term aeromechanics basically is combination of your aerodynamics, structural mechanics and flight mechanics, okay. So these are the 3 core pillars of aerospace engineering per se, and together we call it aeromechanics. Why we have to look at aeromechanics? Because if I want to design a aerial system, or if I want to design a controller for an aerial system, which means an autopilot, or if I want to analyze, understand the performance of an aerial system, this is the core fundamental, okay. Once you have good understanding of this entire concept, you are in a good shape, you can do back of the paper calculations to immediately estimate, okay, if I am building a new thing, how much battery I am going to require, what kind of propeller I am going to select, why should I select this, why it will work, why it will not work, all those ideas you will be able to understand if you get the basics of this course actually, okay. So this is a very basic course which will build you the correct background. So you will be even able to write some basic simulation codes to predict the aerodynamic performance of fixed and rotary wing vehicles under different conditions, which is very important, because yes, simple calculations are fine, but if I want to analyze something in more detail, I should be able to write basic simulation codes. And from time to time, I mean, because I do a lot of UAV design myself, and my students have been doing a lot of work in this domain, I will keep trying to highlight what are the key concepts in aeromechanics which govern different aspects of design of an aerial vehicle. Okay. So, we will keep looking at those things also as we go forward. Okay. Coming back to the basic syllabus, we will start with basic historical development, introduction to unmanned aerial vehicles, what they exactly are, how they come upon, and what is going on right now in the world. Okay. Then we will broadly focus on, so the whole course will be divided in sort of two parts, before midterm, after midterm kind of thing. And so, first half we will try to cover the basics of fixed wing type systems. Okay. So, I will go into aerodynamics, a bit of flight mechanics, and little bit of structural mechanics, okay. Just to give you a flavor of that, I mean, how you decide, I mean, how strong a structure should be, right. I would not make you to design the structure and do structural calculations. Some of you may be already familiar with those because you are coming from mechanical background or aero background, while I mean so that we will not go there actually, but you will get the basic idea that okay, this is how I determine the strength, this is how I determine that okay, my structure will have so much of life. It is very critical, not so much for a small drone, but if you are building a drone which is lifting 150 kgs or 50 kgs, right, these are enormous big heavy drones weighing hundreds of kilograms. So, each and every component is then very critical. So, you cannot have a single point of failure, that this fails, my whole thing collapses. Okay. It happens, I mean, even now it happens, it is not very easy to overcome all those things. So, we will give you appreciation for all those things also in the course. So, first half we look at the fixed wing aerodynamics and performance, second half we look at primarily rotary wing aerodynamics and performance, we will look at even propeller theory. So, propeller theory is different from helicopter theory, there are similarities, but they are different. Okay. So, propeller is a rotor which is in axial flight all the time, while a helicopter or a quadcopter is a rotor which is in edgewise flight. So, there are two ways of flying, I mean, my propeller can go like this or propeller can go like this. Okay. So, this is what I mean you do in quadrotors or in helicopters for that matter. Okay. So, they have similar principles and that is all we will try to highlight. Okay. I will very briefly touch upon the flapping wing part, okay, because it is still a area of research. You do not find, I mean, them readily getting used in real world because it is a very complex technology. So, I will highlight the challenges and things like that about that. So, we will look at that, and finally, if there is still time left, we will look at a bit of rigid body dynamics of UAVs. Okay. I mean, rigid body dynamics is common thing for every platform, but if we have time, I will just give you some example of flight dynamics modeling and so on to sort of give you some stage for courses which you will take in the next semester. Okay. And grading policy, so this is already uploaded on your Pingla, so you can go and take a look at that. Some references are mentioned, but again, I mean, this is a PG level course, so you will not find a direct textbook because no textbook exists for this kind of course. It's there are reference materials. So, for fixed wing, I mean, Anderson's book is pretty good actually. Interestingly, both these books actually are from authors who were actually faculty at Maryland. Okay. So, helicopter theory to me was taught by Gordon Leishman, I mean, he was my teacher. Anderson was also there then, I mean, he retired after a couple of years when I joined PhD in Maryland. Yeah, just to give my background also, I did my bachelor's from IIT Kharagpur and did master's from Maryland as well as PhD from University of Maryland College Park. Okay. So, both these teachers were actually there, and both these books are actually like legendary books in these two domains actually. Yeah. So, that is a interesting trivia for you. Professor Venkatesan's book is also there, he was faculty here, I mean, he was the person who hired me in the aero department here. So, he has also done a lot of work on helicopter technology as such. Okay. His lectures on helicopter theory are also available on YouTube if you want to go and look at that. Okay. Alright, so that is all. It is a PG course, 100% attendance is compulsory obviously, so that is expected. You should never ever miss any class in your PG course unless until there is a very absolute reason you are not well and so on, of course. I mean, so you are sick, I mean, I do not want you to come here, but other than that, I mean, do not miss classes because that is the best way to prepare for your, and this is the grading policy, assignments, midterm exams and final exam. Okay. So, we will keep giving out assignments at regular intervals, which will help you decide your grades actually. Okay. So, that is a basic idea. Okay. Alright. So, any questions about this grading policy or any such things? Alright, fine. So, then let us jump into the basic of the aeromechanics of unmanned aerial system. Alright. So, what is exactly unmanned aerial system? So, a lot of people who are actually confused about, I mean, they come and tell me, oh, is it a UAS or is it actually a drone? Is it a UAV? Is it a RPAS? So, all these names are actually catering to the same thing. ideally the more respectable name for drones is unmanned aerial system, because drone is a very generic and I would say misnomer for something which is fairly sophisticated, fairly well designed. I mean, and with AI and everything, it is becoming very, very intelligent day by day. Right? So, calling it a drone is actually a disrespect to this system. Why? Because drone means something which is a zombie. So, there are drone bees. If you go and look at bee colonies, there are worker bees which are just there. I mean, they just obey commands. So, drone is something which just obeys command. So, a drone could be a ground robot, it could be a walking legged robot or a dog robot, or it could be an underwater vehicle. So, drone is a very general term of anything which actually obeys command, it is a drone. So, but somehow I mean press and everybody has popularized this term so much that we only think of unmanned aerial vehicle as a drone. Okay. I mean that is a more common term, but the correct term is actually unmanned aerial system, and more recently I mean people have modified this term to make it gender neutral. So, what is the new term? Uncrewed aerial system. Okay. So, not unmanned, not unwomaned, uncrewed aerial system, okay, because no crew. Okay. Crew is a gender neutral term. So, that is the latest terminology which is used. So, you would not want to call it unmanned, seems very biased. So, call it uncrewed aerial system, but I mean we call it UAS, right. So, UAS is UAS. Sometimes I mean at smaller level or scale we call it aerial robot also, because these are very agile platforms, they can do all kinds of things. So, they can be called as aerial robots or looked upon as aerial robots also. And what I mean now recently NVIDIA CEO has called everything which comes in the realm of robotics as physical AI. So, beyond I mean your software AI where you have this chat bots, I mean chat GPT and your various tools, I mean whatever are there actually, like I mean Google have their, Facebook has their Meta AI and so on and so forth. So, there are so many I mean AI engines available, they are all mostly your speech engines actually. Okay. So, they can interpret text and reply in text, and they are very knowledgeable now because they have mugged up so much of information, right. So, NVIDIA CEO actually has called all robotics related things as physical AI, where I mean intelligence will get exhibited in form of some actual physical hardware actions, not just I mean soft interactions which we normally do right now with AI tools. Alright. So, this is something which I have just copied from internet, maybe Wikipedia or somewhere. What exactly is an unmanned aerial vehicle or an uncrewed aerial vehicle? An aircraft without a human pilot on board. So, there is a fine human pilot on board, there is no human pilot rather. Its flight is controlled either autonomously by computers in the vehicle or under the remote control of a pilot on the ground or in another vehicle. Means I mean it is somehow controlled or navigated remotely. There is no physical presence of a human being on board. So, that makes it uncrewed for that matter, and purely from the perspective of aerospace engineering, we categorize them into these three broad categories. Okay. So, let me turn on the laser pointer, right. Okay. So, we categorize them into these three broad categories, purely how they fly. So, fixed wing, as the name suggests, the wings are fixed. So, you have wings on both sides and you need to generate some relative motion of the wing with respect to your air, and only when that happens there is relative airflow, you will be able to generate lift. How it happens actually, I will go into the basics of all that I mean also in coming lectures. So, that is the fixed wing. So, here I put a picture of General Atomics Predator drone which India is looking to buy for a huge price, billions of dollars for that matter. So, you can understand I mean that if you end up building something like this, I mean you are going to become a very rich guy, right. So, yeah, I mean as engineers it is our goal, right, I mean to build the economy. I mean we are there to build stuff, build technology which serves mankind. I mean especially for civilian applications, not so much for defense applications. So, there I mean you intend to not just save lives, but sometimes I mean take lives also, which is what war demands, but anyway we are not going to go in the philosophy of things. Then the second type is rotary wing. So, rotary wing as you can see is why rotary, because your wing is rotating now. Okay. So, you have a wing which actually spins like a helicopter blade, your fan, so they are all rotary wing systems, where my wing now can at one place I can keep spinning it. So, there is always a relative speed between the airflow and your rotor or your blade, and therefore, I mean it can generate lift all the time, it does not have to run. Okay, it does not have to fly related to the air. So, here I put a picture of Northrop Grumman MQ-8 Fire Scout, which is also a very popular platform with US Navy and several other people. It is an autonomous helicopter capable of taking off and landing from a ship deck. I would say, I mean, state of the art of rotary wing UAV. And then the third kind is your bird type, where we are trying to copy nature. It is never easy to copy nature. If we had been at copying nature and tried to build our airplanes that resemble bird and do flapping of wing, we would have never flown probably, because you can clearly see, I mean, Airbuses, Boeings, Bombardiers, none of our airplanes actually do this, right. So, they are not flapping their wing to become airborne. So, it is very hard to do that actually. So, nature has perfected that. I mean, the birds have special adaptations, they have hollow bones, unique muscle structure, feathers, they can morph their wings whichever way they want, and they can do lot of interesting maneuvers, and they can fly very, very well. But scaling that to a larger scale is not easy. Even birds, I mean, you do not see, I mean, them of the size of a giraffe or a hippopotamus, right. You do not see a flying hippopotamus, right. So, you cannot, that idea, I mean, yes, there is thing that, I mean, you have dinosaurs flying at one point of time. I mean, there some of them were pterodactyls and all were fairly big animals. So, but now, I mean, if you see in the modern day world, I mean, you do not have very, very big birds, I mean, beyond tens of kilograms. Okay. You do not have actually a 500 kilogram bird, okay, or a 1 ton bird, right. So, this is actually even difficult for nature, we can see, and almost impossible for human beings. So, this picture is that of a AeroVironment nano hummingbird. It is actual real bird which flies, in the sense it looks exactly like this. It is not a toy bought from Big Bazaar or somewhere. And interestingly, I mean, this 2 prototypes of this system were built almost a decade back, around 2012-13, by this company AeroVironment. AeroVironment is the same company which actually has built Mars helicopter. How many of you are aware of Mars helicopter? What was the name of the helicopter? Ingenuity. Yeah. So, Ingenuity is the first drone or unmanned or uncrewed system which flew on a different planet, and it was designed for only 5 flights, each flight lasting 1 minute approximately, and it surpassed that the design specs which was put. It flew for 72 times, and finally one time, I mean, it actually had a hard or crash landing when its propeller got broken. Now, nobody is there to replace that, so it cannot fly now anymore. So, that is also the same company which AeroVironment which built that system, of course, with NASA JPL and other people. So, this particular bird, this tiny looking bird, which has a really tiny pinhole camera, probably analog camera, which gives you very hazy, poor quality video, as if taken from a very old age camcorder kind of thing, and the cost was $3 million. So, with the current rate, it is 25 crores to build 2 prototypes. So, interestingly, I mean, one of my friend knows a guy who actually was part of the project. He asked him that, I mean, what are you guys doing with this actually? He said, it's kept nicely there. You don't want to break it. So, that's how it happens actually. Okay. So, although this is a slightly oldest slide, but I mean, the reason why we are all studying this actually and why we want to do this is because the market of unmanned aerial system actually has exploded already in the last decade, not this current decade, especially in the commercial domain. Around 2015 to 2020, in America alone, millions of hobby drones were already getting sold, and that is how DJI became the pinnacle of this technology. I mean, they are the world leaders in commercial drone technology right now, and they have done, I mean, almost entire vertical integration, and they are able to offer some insane technology at really crazy price, very, very optimal price, and it's almost impossible for anybody across the globe to beat them, including the very sophisticated, I mean, technologies coming out of America and elsewhere. There is a company called Skydio. They were trying to compete with DJI, and finally they had to fold out their commercial arm. They are now only selling it to Army and other people, because they could not actually beat them either at price or at quality. Okay. So, that is the key challenge, but yes, so commercial market already exploded in last decade, and now we are seeing sort of a reinvention of sorts in the defense market, because some recent wars have really opened eyes of all the armies and all the air forces across the globe and all armed forces, by looking at, I mean, what happened first in Azerbaijan, Armenia, then what happened in Russia, Ukraine, and it is still going on in Russia, Ukraine, and our own recent experience with Pakistan. So, So, drones are now having a tremendous and enormous impact in both commercial space as well as the defense space. And if you, so this market now as per the latest number, these numbers are older, and I have some slides from studies which have been done recently. People are talking about by end of this decade the global market to go to almost 20 to 25 billion dollars actually, by end of this decade, which is fairly big number, $25 billion, and out of that India itself may be contributing to, the target of course is to contribute to at least 20% of that. That is our goal. Are we able to reach there? We do not know. Currently the whole market is around like 10 odd billion dollars, and India's share of that is probably actually not 10, probably more. Okay, fine. Maybe next class I will show you that slide also, which I recently got from some source. So the numbers are pretty big actually, and very promising. In India itself, we see by end of this decade, this should grow sporadically, because in the recent war we realized that we do not have enough inventory of our own, and we need to build up that, because if we engage in any war which is going to last for the kind of duration Russia and Ukraine are fighting, then we will not have anything left pretty much. So we have to start working on that. Coming to the application part, well, it is pretty much now left to our imagination. The most common and the early uses for UAVs was actually an eye in the sky robot. So we say that it is a camera which I put on this aerial platform, which would give me very good coverage. So if I am in the battlefield, or if I am in a disaster scenario, or if I am in any construction site, aerial view of things gives me a very good perspective. So I can immediately see what is happening over the hill or around the corner, as they call it. So with this flying camera, I can get real time both day and night video feed or pictures and so on, which allows me to have real time situational awareness, which is very, very important, especially in scenarios when you are dealing with hostage situations, what we faced in Mumbai attack or attack on parliament and so on. Every now and then, in Jammu Kashmir we have hostage situations, where there are people who are terrorists who are holed up inside holding civilians hostage. So all these scenarios, this kind of having a flying camera, eye in the sky, is very, very useful. So that was the first and foremost application. But now we have lot of new applications coming up actually. It's not like it's very recent, but we are seeing the level of impact it's causing now in a big way. So you have now drones which are weaponized, they can carry ammunition, they can carry guns. There are drones which can go and hit on the target and explode themselves, so commit suicide, harakiri or kamikaze as you want to call it in Japanese terms. So the applications are now unlimited. You can put SAR payloads, you can put ELINT, communication intelligence, electronic intelligence. So there are different payloads available which you can put on these drones, and you can carry your mission. You can carry out a huge amount of loads and eventually even people. There are news recently where our neighbors have sent people on drones, hanging from drones. So this that is the level we have reached. So you don't have to build an aircraft, you just build a drone which carries a person. Very risky, but yeah, people are doing it. They don't require DGCA clearance to fly anyhow. So yeah, coming to civilian domain. So civilian is also very, very important as much as defense, because if this part doesn't evolve, we will not be able to realize the full potential. Either from the building the whole ecosystem in the country point of view. So here you can have power grid sector. They are seeing a lot of adaptation from drones for surveying, mapping, laying out of power lines, maintenance, traffic monitoring. Disaster response management is a huge area where drones can make a big impact. Some of our drones built at IIT Kanpur were actually used in some major recent natural disasters. So one was actually when this cloud burst happened in Uttarakhand, and this hydel power plant was washed away, and there was a lot of destruction. So there our drones were deployed to do the damage assessment, and although we were called very late, if we had been called earlier, we could have made even bigger impact, because one could have actually supplied your food items or drinking water and all in the flooded areas. And recently this tunnel was had capsized, right? Chilkera tunnel, and a lot of workers were actually stranded and trapped for several days. So our drone was the first drone to reach on the spot. We were actually, through some link we were called from PMO office, and our drone went inside and we did 2 missions inside the tunnel in pitch dark to gauge the extent of damage there. And we found that, I mean, there was absolutely no opening there. There was a big rubble pile and it was too risky to go inside and even to look for an opening from that side. So, this was conveyed to NDRF and other people, and then after that they shifted their focus. Then they started to rescue these people from other side, because they realized this side there is absolutely no possibility. So, that way, I mean, these drones actually could be a lifesaver also. So, they have a lot of roles to play. Yeah.
So that situation, we had to take people to sacrifice their lives so that they could just pile up sandbags on it. So instead, if we had drones, we could have averted that situation. We could have used drones instead.
Absolutely, and this was actually indeed done. I mean, when this Fukushima nuclear disaster happened in Japan, okay, after tsunami and everything, earthquake happened there. So, the first thing to reach that site was actually a drone, drone made by this company Honeywell. So, that was the first thing which actually reached there for disaster response. And Japan actually, though they have been very advanced in robotics traditionally, right, I mean, they have been a powerhouse in robotics, they realized that they were not very capable in the area of drones as such, because this drone is actually an American drone which was used there. So, the first thing to reach there on the site to assess things, and they even sent a robot actually which tried to climb inside the stair climbing robot, and after a point, I mean, it got stuck because it actually had a tether cable to communicate with it. So, anyway, so yes, drones, I mean, could make a huge impact actually, because why? Anything that is dull, dirty or dangerous, I can get it done using a drone, or for that matter uncrewed aerial system, right. So, yeah, in India we are seeing huge amount of work going on in agriculture domain. Why? Because IFFCO has made a particular urea which can only be mixed in water and sprayed on crop. You cannot put it at the roots, okay, it has to be sprayed. So, they had really pushed and supported the deployment of drone in agricultural sector. Mining industry is seeing a lot of this application, payload delivery for even defense applications. In civilian side, it has not picked up so much, but eventually it will happen. There are already countries who are doing this actually in African countries. There is a company called Zipline. They have been initially doing blood delivery, but now they are also looking to do this commercial delivery in some European countries and some other places here. So, these kind of things will also come up eventually. So, it is up to our imagination to see where all we can deploy drones, how to make our lives easier. Yes, so I will show you some videos now, but yeah, before that, I mean, these are some pictures of big popular fixed wing UAVs, mostly in, so there are other categorizations also for drones or UAVs in terms of the lifting capacity, payload capacity, endurance time and so on. So, these are all big drones. So, this you can see these all belong to MALE and HALE category. What does it stand for? MALE is medium altitude long endurance, HALE is high altitude long endurance. So, these drones are there. So, these are American drones for General Atomics, these are our own drones. Now, there are better versions have been made by DRDO and they are still working on to develop it further. To build their HALE drone, they have approached IIT Kanpur, and I am about to submit a proposal to them to work on this project together and see how we can improve it further. This is an example of, okay, let me, alright. So, this is because we talked about flapping wings, so I will show you some videos of those things. So, this is again a very old video taken from internet. This is Festo's smart bird. Okay. A company, this is a European company called Bionic, I think. So, they specialize in making these biomimicking robots, robots which would sort of copy nature. So, they have made this bird, they have made a dragonfly and several such robots, and this is almost again, I mean, easily 15 years, 12 to 15 years old video. So, something which has been built long back, and very similar type of flapping wing bird was built here in IIT Kanpur actually by one of our PhD students, Joydeep Bhaumik, under Professor Devabhom Das's guidance actually. So, he had done a lot of work in this flapping wing domain and built some really good technology, but the key thing is that it is very, very challenging. You may have seen Uri movie, right? In that you saw that bird doing some really amazing fantastic things. Those are just purely imaginary, although that particular bird is actually a real bird. It is made by a European company, I do not remember the name. What they use that bird is for actually to scare other birds away. So, they are like scarecrow. Yeah. How? So, that particular bird which you saw is actually a replica of a real bird called peregrine falcon. So, falcons are predatory birds. So, they have made it like that. So, this peregrine falcon is sighted in an area, other smaller birds will get scared and they will run away. So, idea is to fly it in the crop fields. So, now birds will not come and eat away your crop. They also use this bird to drive away bird population near airports also. So, this company was built up purely around this idea that we will make these scary looking birds which will drive other birds away. But it is neither autonomous, it has to be flown by remote control and it has very limited flight time. It could not do any of those things which you saw in that movie. So, in reality no such technology exists till date which is of such capability. Yeah.
So, what were we actually looking from flapping wing UAVs?
The good question, actually we will come to that. Okay. So, we will talk about each of these platforms, I mean, and see what is good about them, okay. Why should we work with them and why do we require so many different types of drones? Can't we make just one drone which does everything for us, right? So, we will try to answer those questions. So, here is another rotary wing type, I mean, drone which is one of the smallest commercial unmanned aerial vehicles actually. You may think, I mean, it looks like a toy which you buy from a toy shop, but again it is a very, very expensive piece of toy. It is called Black Hornet Nano. Originally it was built by this person, his name is Peter Muren, from Norway. His company is called Prox Dynamics and he is an electrical engineer by trade. So, he is trained electrical engineer, but he had tremendous fascination for aviation and aerial vehicles. So, even as a hobbyist, I mean, he started building some toys and he has a knack for miniaturization. So, he is very good at making really, really tiny miniature things. So, first thing which he built actually was, let me move ahead and show it to you. Yeah, so he built this tiny toy flapper first, okay. Then he built another tiny helicopter, this toy helicopter he built, okay. Actually before this, I mean, he built this other helicopter, yeah, coaxial helicopter. So, this is the kind of scale he was building things at, see, super tiny things. This is the helicopter he built and he sold this design to a Chinese company and it actually got sold in market as first remote controlled flying toy. Okay, so, it was a big sensation, it was sold in Radio Shacks in America and many other places. Interestingly, it does not require any autopilot, it is passively stable, it has just only one channel to control which is the throttle which will make it go up and down. Okay. So, there was no control, it would just fly randomly here and there, but it was stable and you could easily fly, a kid could easily fly indoors and be happy about it. Okay. So, he built this thing and this was called, I think the company was Airhawks or something, I think he will show that also, yeah, Blade Runner, yeah, this was called Blade Runner. So, this was his first thing which he built and sold it as a toy, and with that, I mean, whatever money he made or so on, he then went on to make this Black Hornet Nano, and till date it is a remarkable piece of object. It is a very tiny, barely 30 odd grams weighing drone which flies for almost 30 minutes. Okay. So, and not even being an aerospace engineer, I mean, he had brought in some really interesting innovations in this design. Okay. Later on he sold this design to this company called Teledyne which makes this FLIR cameras. Okay. So, FLIR is a leader, global leader in thermal imagers. Okay. So, all night cameras, so they integrate day and night cameras into this and they made some further improvements. So, it is now a popular thing. Can you guess the price of this? Okay. $20,000 is somewhat okay, but I mean it's more expensive than that actually. So, rough, sorry, 70 is thousands of dollars, yeah, somewhat like that. I mean, so it costs around like 80 lakhs, I mean, for one set, which probably has 2 birds and 1 control unit, I think. Yeah. And in India there are people who are using it, I mean, special forces, your agencies which are involved with safety and security of I mean of powerful people, I would say. Yeah. So, some such special forces are using it for room intervention and many other applications, but the key challenge is that I mean I have also heard funny stories about this. You can understand, I mean, it is a very expensive piece of equipment. So, if it gets lost sometime, I mean there is wind, some connection gets broken or whatever, some malfunction, and it gets lost. So, they have to send search parties to go and recover this, because 80 lakh, right. Okay, so, somebody will have to write lot of reports to say that it is lost. So that is the interesting thing about this, but it is a beautiful piece of technology, I mean. Okay. So, you can see, I mean, how you can make a toy and become very rich. So, this guy, I mean, single handedly, I mean, he used to make each of them by hand, he and somebody, I mean, his team members. Okay. So, later on when they sold it to Fluor, I mean, they scaled up the production, but they realized, I mean, it is unique thing. So, like monopoly, right, I mean, so you charge whatever price you want. Okay. So, the bill of material may not be so much, but they are still charging lot of money. So, the question is that, I mean, when you go to such miniature scales, things are not the same. Most of you are not aero guys, so you will may not probably fully appreciate what could be the challenge. We'll come to that, I mean, later on, I mean, once we progress further in the course. So, this actually is again a slightly old chart, but this was I mean, sort of built around the original definition of unmanned aerial vehicles, which was given by DARPA almost 35-40 years back. Are you familiar with this organization called DARPA?
It created the internet as well.
Yes. So, internet also came out of one of the DARPA challenges. So, DARPA is a futuristic technology think tank and a funding agency. It is an arm of DOD in America, which supports and funds projects which are almost like Mission Impossible, not the movie, but almost impossible to solve, where, I mean, your chance of success in that particular project is less than 30%. Normally, if somebody says, okay, go and do this thing which has very less chance of success, you will say, sorry, I do not want to do this because too much risk. But unless and until you take risk, you cannot innovate. If I know what I am doing, then I am not innovating actually. I am just replicating what I already know. So, I will always be stuck with that same level of capabilities which I have been taught. So, to think out of the box, DARPA actually gives this kind of impossible challenges. So, as the story goes, in 1975s, 1970s to be precise, I mean, they gave some challenge to some engineers and told them, I mean, make these two computers talk, and that is how internet was born. So, they tried to do the networking between these two computers, and eventually is what, I mean, you are seeing in the current day. So, you see, I mean, they are able to sort of invent the future in some manner. So, they actually had given the definition of this micro aerial vehicles. So, they set a target that build an aerial platform which would be able to fly for 60 minutes. It should not weigh more than 100 grams, and it should not be more than 100 mm in any dimension, something like that. Okay. So, that was the definition of a micro aerial vehicle given by DARPA in 1990s, early 1990s. Okay. And based on that, I mean, a lot of people tried, and even in India there was a national program on micro aerial vehicle almost 13 years ago, around the time when I have joined IIT Kanpur, and in that, I mean, everybody was trying to achieve that same target. So, you see here, this graph shows you on y axis your flight time, x axis your weight. It was not very difficult to build very small and lightweight crafts. So, people could make things which were actually weighing 20-30 odd grams. So, you see, this is 19 grams, 11.5 grams from Caltech, the Black Hornets. I mean, 16 gram is not really the correct weight. I mean, it weighed around 26 grams, something like that. Yeah, but whatever. Yeah. So, AeroVironment 170 grams, Black Widow 80 grams, 110 grams. So, these kind of things, I mean, people try to make, and if you see, flappers and rotors, rotary wing systems could be made very lightweight, but none of them could actually give you the desired 60 minutes of endurance. So, this is the goal. 100 grams, 60 minutes. Till date, this has not been achieved. That you make something which actually weighs less than 100 grams and flies for 60 minutes. Why? Well, I will try to give you an answer to that. But yeah, I mean, fixed wing drones, if you see, or fixed wing UAS, some of them were able to reach. So, this 170 gram AeroVironments, the same company AeroVironment was, could actually with 170 grams fly for 60 minutes. So, which is quite remarkable, but that it is almost double the weight, right. And that point of time, I mean, toys. So, this is again from some time back, these 300-gram toys. Even now, I mean, you can go and buy a quadcopter probably weighing 100 grams or 150 grams toy from a toy market, and it will give you barely 5 to 10 minutes of flight time. So, this remains as a challenge which still has not been solved, but that is one side of the problem. I mean, it is not like, I mean, I am always only interested in small and miniature vehicles. So, this presents a slightly different kind of challenge. When you go to larger scale, that presents a different type of challenge altogether. Okay. And through this aeromechanics course, we will try to establish and understand what drives these challenges, what is the fundamental physics which would govern the design of these. So, question is why this small tiny craft. So, in big craft, flight time is not a big problem. I can give you a 2.5, 3.5 kilos quadcopter which will easily fly now for 1 hour, no issues. 70, 80 minutes also I can give you with some over designing and so on. But what is the challenge when I go to smaller scale? So, that actually comes from something called Reynolds number. We will study all that, and we will probably look at a graph which will give you the idea that okay, what happens to my lift and drag and these parameters, because flight is all about lift and drag, as we will see as we go forward, and at that point we will try to answer this question. So, keep this in mind. I will not give you an answer right now because you will not be able to digest the whole answer at this point of time. So, this is DGCA's definition. So, since we are looking at introduction of UAS systems, there are different ways to categorize them, different way to differentiate them. I gave you one differentiation where I mean I talked about the aerodynamics, fixed wing, rotary wing, flapping wing. Now, this is the DGCA's definition where they have categorized purely based on the weight. Why on the weight? Why should you categorize based on the weight? I am sorry?
The weight would also affect its size.
Yes, yes, but why weight? They could have said size.
To lift that much weight lift.
Yeah, but why should I say, I mean, okay, this less than 250 grams is nano and micro is up to 2 kilograms. Why would DGCA give this kind of demarcation? They could have said, okay, whatever I mean you make, I mean, it is a drone. So, the categorization is actually because they would specify different set of rules and regulations for different categories of drone. Why? If a 250-gram drone crashes on a house, what happens? Nothing happens, right? Drone crashes and drone will go into pieces, but nothing else happens. Okay. But if my 150 kilogram drone falls on somebody or some property, right, somebody's vehicle, that can create an enormous damage. It can kill somebody also easily. So, that is why I mean this weight actually becomes important. So, the idea is to bring in weight because it will reflect the kinetic energy of the system. So, small drone also flying at higher speed will have high kinetic energy, right, and a large drone flying at a lower speed would still have slightly higher kinetic energy. So, idea is to relate to the kinetic energy, because kinetic energy is what is there, energy stored in the drone, and that is what is going to create the damage. So, that is the perspective why people try to categorize in terms of weight. So, nano is up to 250 grams, micro is up to 2 kilograms, 2 to 25 kilogram is small, 25 to 150 is medium, and beyond 150 is large. So, the regulations for beyond 150 would be more stringent to get it certified for operations. See, every aerial platform has to be certified eventually in some manner or the other. Why? Because you have to prove the airworthiness, that is, it is worthy of flying in air and it is safe to operate. It will not actually crash, land and create damage for that. Yes, even with all the certification and everything, things crash because there could be malfunction, systems may fail and there could be critical failures. But idea is to be able to avoid that as much as possible and ensure that I mean all the safety features are incorporated and every possible challenge that can happen is at least looked upon beforehand and understood that if this happens, this is how I mean one has to react or your system has to react. So, that is the idea about demarcation which is done by DGCA's drone rules from 2021. So, these rules came out in 2021. Before that, until 2018, unmanned aerial systems or uncrewed aerial systems were completely banned in the country. If any of you were sighted with a drone in your hand, police will come and arrest you. So, MHAs in terms of people word of people from MHA, they said our instruction was that put the drone in sack, put the guy in behind bars. So, that is how it was actually. So, that is something which really hurt us also. While I mean globally we are seeing serious upsurge in technology development, in India it was only happening at a very limited level, because we are resisting this. See, every point of time, I mean our police forces are worried that somebody with a drone would be able to create some damage somewhere. Okay. So, they say I mean make the rules very strict, very difficult. Okay. Nobody should be allowed to operate. I mean you should require 10 different certificates and license to get permission to operate a drone. But the fundamental question is, why would a person who is engaging in unlawful activity obey rules and regulations? I mean he will say, oh, get a type certificate from DGCA drone. So, this particular drone will be used for killing people. So, it does not work like that, right. So, it is not right on part of I mean enforcement agencies and so on, but finally sanity prevailed. Okay. And somebody in DGCA said that, oh no, I mean this domain has to be pushed, and actually PMO office, they themselves intervened. Even our honorable PM, he really intervened. He has very keen interest in building drone technology in the country. So, that is why you have this drone Didi scheme and so many schemes being launched, and he keeps pushing actually from his side that I mean this technology we have to become a leader, okay. One of the key players on the globe, and that actually has only started to happen in this particular decade. After 2021 drone rules came out, because they were very industry friendly. It is still, I mean it is a good start, but there are still more reforms which are required to I mean make things happen at a much faster pace, and there is actually continuous effort going on. Recently there was a meeting at a very high level actually involving PMO, DST, your entire armed forces, your vice chief of army, air force, I mean vice chief probably or chief, I mean so all these people were called upon actually. Okay. Ministry of Electronics and IT, because people think of drones as an electronic entity. It is true about smaller drones, but larger aerial vehicles are aerial vehicles. They are not just electronic piece of electronics which is flying. Okay. So, that way I mean DGCA was involved, I mean METI was involved, MHA is involved. So, all the stakeholders were called upon, that industry people were there actually to understand I mean what further needs to be done to really push the industry in a big way. And yeah, so that is how things are actually in this sector. So, these are some more further classifications. So, as you saw like DGCA, I mean one can classify based on the payload capacity. So, one can call them as mini, nano, micro, etc., small, large, with a different category of drones what DGCA actually has mentioned. So, before I mean this unmanned aerial systems or uncrewed aerial systems became more popular or became something which people started taking notice of, there were already remotely piloted aerial systems. So, on army side there is also this common term, because army operates these Israeli drones, Searcher Herons in India, and then like that I mean anywhere else, I mean like Americans are operating Reaper, Predator, Sentinel, so many these different drones. So, all these drones actually are not entirely autonomous, they do not decide where they are going to go. There is a pilot or a human being in the loop who is operator, sits on the ground, and he sort of gives commands through the communication link to make it go, but they are not continuously piloting it like a pilot. But earlier editions of these industrial UAVs were actually remotely piloted. So, there has to be a person in the loop. For example, in Japan they have been using unmanned helicopters for crop dusting, crop spraying of pesticides and urea kind of stuff for last 2.5 decades, if not more. So, you are familiar with the company Yamaha, right? Yeah. So, Yamaha built this industrial UAV called RMAX, which could lift almost 40 or 50 kilograms of payload. So, it could lift really big tanks of this spray and go and do spraying in huge farms. So, they have been using it in Australia, America, Japan for quite some time actually, almost 20 or 30 years. Later on, I mean this particular design was sold by Yamaha to Northrop Grumman, I think, and they converted and made it a weaponized version of that called RBAT. So, RMAX became RBAT. So, what Yamaha did, I mean they made another model with slight small deviations and they call it Fraser. So, now RMAX has been replaced by Fraser, which is almost same unmanned helicopter, still used for this kind of application. but they are all remotely piloted. So, there would be a pilot who is actually flying it manually. Nowadays, I mean in agri or anywhere else, I mean the drones are sometimes piloted, but many a times I mean they will be pre-programmed. Okay. So, you will upload a mission and it will fly as per the mission. If there is some disturbance or wind or something, then maybe a human pilot may take over the controls, but otherwise it will be able to fly on its own pretty much. Okay. So, many such things were there already in the rotary domain, which were there. So, you see 1960s, this is from 1960s, some of these are actually from 80s and so on. I should have probably put a picture of RMAX also here, because it is a fairly old, almost 30-year-old helicopter design, which was very popular in the agri domain actually. So, this brings us to our main question that okay, so we saw some kind of categorization for these UAVs, primarily two category. One is from aerodynamics point of view, other is from weight point of view. We will see some further things from the perspective of say defense applications. There is another demarcation which I will talk about in the coming slides. So, coming back to the aeromechanics perspective, the fixed wing has source of lift is the wing, which is fixed. The good part about these kind of systems is that this is a very old established technology. I mean Wright brothers flew their first aerial vehicle almost a century and 122 years back to be precise. Okay. And these are fairly easy to control, controls are very simple, easy to understand. The technology is very scalable. I can have a fixed wing UAV which you saw some pictures weighing from 100 gram to 3 tons or more. And as a matter of fact, I mean the current commercial airplanes are almost like a UAV, in the sense that I mean almost every aspect of that has been automated already. There is only a pilot who actually manipulates control when required. Otherwise, I mean it can pretty much do everything on its own. And the key advantage that it offers is that the fixed wing lift actually comes at a lower power consumption, and therefore, the fixed wing type crafts compared to the rotary wing counterparts can fly for longer periods of time, which is the endurance, and they can fly farther and farther away, which is the range. So, the distance travelled. So, they will always offer you more time and more distance for flight. So, that is the main advantage. But what is the disadvantage or challenge? It cannot stay at one place, because the moment it tries to stop, it will lose the lift and it will drop off. So, that is called stall. So, it cannot hover, and it will require some kind of mechanism to make it airborne, where it can run and accelerate and gain the speed. So, it will require some runway, some catapult, some mechanism to take off and some mechanism to land safely, if I want to recover it also, and it cannot stay at one place. So, this actually sometimes makes it difficult to use for certain applications, and that is where rotary wing comes in. Here the source of lift is your rotor. They can hover very easily, they can maneuver easily at very low speeds. So, if you have to fly in tight corners, constrained spaces, this is the ideal platform. But even though it is designed for hovering application, it is by default not stable in hover. So, this would give you reference to 3 Idiots movie, where I mean you see, I hope you have seen that movie, it is probably old for your age, but still it is a popular movie. So, you may have seen it. So, in that you see Amir Khan is trying to make this quad rotor fly and he tries to fly and it is unstable. Finally, he does some measurements from scale and he somehow makes it stable, which is very weird. But yeah, so all these rotary wing platforms some kind of require some kind of stabilization, either through mechanical means or through electronic means. So, you will have a mechanical stabilizing system or electronic stabilization system, which will be basically your autopilot. So, they are unstable in hover, but it is fine. I mean that can be easily managed with a simple autopilot on board. But yeah, they have also suffer from problem of lower endurance, they may be more noisy and so on and so forth compared to fixed wing type. And flapping wing type, here the source of lift is the unsteady lift because of the flapping motion of the wing. So, as a result, I mean the flapping wing crafts can fly at low speeds also. In some of them actually can even do hovering flight also. For example, there is a bird called hummingbird. Have you seen any hummingbird in real life? No. Okay. So, in campus you will see their close cousins, sunbirds. So, if you see the trees which actually have this yellow flower, you will find these very tiny birds hovering there. The males are actually very bright purple and navy blue kind of plume, and females are yellow brown kind of color actually. So, they are very tiny birds, they almost hover, they cannot hover perfectly like I mean your hummingbirds, because they are slightly different species, but they can almost hover because they also go and drink nectar from these flowers and so on. So yeah, so there are some birds which can do hovering flight also. So they actually have advantage of unsteady lift because of this flapping motion all the time. But why it is interesting for defense application is because of the good camouflage. So almost a decade ago, or maybe at least 7-8 years ago, a team from IIT Kanpur had gone to Udhampur and had shown these flapping wing birds to the then army commander there in Northern Commands actually, and they were very impressed and very excited actually. So they were keen to see this bird flying in Leh Ladakh, but Leh Ladakh, I mean, normal time also you will get 5 meter per second, 10 meter per second, 20 meter per second wind speed very easily. And these birds, I mean, if you have 5 meter per second wind speed, it will start flying backwards. Why? Because they do not have that kind of actuator power available, and they are not light enough, efficient enough to be able to fly at good enough speeds to resist wind. So these are the challenges. The scalability and mechanical complexity is a big challenge for this kind of platform, and therefore research is still going on. You do not see a commercially available product in any space anywhere, either for commercial or defense application, which actually have this kind of capabilities. But the key thing is camouflage. From far away, if I put nice feather, weather, everything and color it off, nobody will be able to tell that it is a real bird or a man-made bird, unless of course, I mean, you have X-ray vision, right, and you are able to see inside. But rather than that, I mean, it is very hard to tell. And there are some interesting videos probably when I come to flapping wing part. I mean, I will show you some videos from IIT Kanpur also, and even birds would actually get alarmed by looking at this mechanical bird, which is there making this kind of mechanical noise, and they will get attracted, especially if you put the wing with a particular color of cloth. Okay. So if you make the wing with a unique color, sometimes they will get really attracted to that. Okay. So we have some of those nice videos from there. Okay. Yeah. Yeah, Black Hornet, I mean, has fairly good speed. I mean, it is a helicopter, right? Okay. So Black Hornet is a helicopter. So they have flown. I mean, recently they failed in one trial actually, okay, for some emergency procurement. Okay. But yeah, I mean, I do not have the exact details, but it operates. Yeah, can fly. It is a good question actually. So I am not sure if that is designed for that kind of application, because finally at the end it is a fixed pitch rotor actually. Okay. But actually it has cyclic pitch control, but not collective pitch control. You will understand these things when we go to the second half of the course. So I mean, it does have a swash plate, but how do they cater for higher altitude? I am not sure. They may be giving different set of blades with higher degree of preset pitch to cater for it, which is possible, not very hard. So it should be able to fly at high altitudes also. I do not see a problem. Okay. Right. So that brings us to this basic idea regarding, I mean, what exactly are unmanned aerial systems about, and this sort of kinds of brings us to our intake program also for MTech degree. So you have come in aeromechanics and design and autonomy. Okay. So this is what actually gives you the key perspective. So broadly speaking, I mean, people who are working in this space could either be belonging to one of the two categories. So either you will be working on aeromechanics and design aspects, where you are looking at the mechanics, understanding the aerodynamics, designing, optimizing systems, which is a very critical task, especially for bigger platforms. It is not trivial at all. It requires tremendous understanding of engineering, mechanical, aerospace to a large extent, and the other side is of course your autonomy side, where I look at stability, control, navigation guidance, basic autonomy, enhanced autonomy, and those kind of things. So this is what I mean you would intend to learn as you go forward, build your skills in one of the two domains. Okay. That is the idea. So you look at design and fabrication of flight vehicles, where we try to do some kind of optimization between. So there is something called MDO, which stands for multidisciplinary optimization. So there you try to optimize a aerial platform by looking at structure, aerodynamics, flight mechanics together. Power plant, most of the time you are not really making yourself, you will buy from somebody, so you will do selection. But yes, I mean, if I have to do a design and manufacturing where I am going to make millions of same kind of system, then I can design my motor also, I can design my engine also, okay, whatever power plant is there. But yes, if I am going to make it in like 10, 20, 50, 100, I will buy it from somebody else. Okay. So that way, I mean, in the optimization process, normally you will not bring in the design of the power plant per se, but you will try to use this MDO to extract the know-how for what exactly is required to meet your mission performance. So the goal of designing any unmanned aerial system is to achieve the mission requirements, depending on what application you are looking at. So when we talk to user, very recently I mean I have been part of Ministry of Fisheries discussions. So, they are now looking to transport fish, live catch, fish catch, especially the perishable fish using drone. So, their requirement is, oh, we want at least I mean 100 kg lifting capacity, then only my fish will be happy to go. So, and at least 10 kilometer of range. So, just yesterday I was trying to explain, now you want 100 kg when the drone will become 300 kilograms at least or 200 kilogram plus, which brings it into DGCA's large category, and then getting it certified will be very time taking and expensive process. So, let us keep it at whatever you can do till 150 kilos, where one can actually lift almost 70-75 kilo of fish and transport it to 7 kilometers, which is fine for them, because the point of catch to the main transportation area is barely 3-4 kilometers actually. Okay. So, which serves the purpose fine actually. Okay. So, and 70 kilo, 30 kilo, I mean you do 2 trips, what is the big deal? Finally, it is about how much water and fish are there inside, right. So, make a slightly smaller tank. It is not that the fish is going to complain, I mean my friend got left in behind. Okay. So, anyway, so jokes apart. So, right. So, depending on the problem statement, I mean user will come and give you very unique problems. Sometimes those problems are not achievable within the constraints which are there. So, you have to be smart enough to check all that and be able to convince the user that no, this cannot be done with the current technology. Okay. I mean Army, Air Force, they come and say, oh, we want everything under the sun. Okay. It is not doable. Right. Sometimes we can do it, other times we cannot do it actually. Okay. So, you have to educate them also by giving them these are the things I mean which we can achieve. Maybe this can be tried in the second stage. Let us start with something which we already have at our hand. So, that is where I mean the optimization becomes very critical, because if you do not optimize, you end up with suboptimal solution which eventually would fail miserably. Yeah. So, it is quite critical to look at the design and fabrication aspect of the UAV. So, that is one part. Second part is of course as important as the first part. So, here we look at sensors, actuators, we look at sensor fusion, get data from so many sensors, try to understand how my UAV is behaving, then command actuators to make it behave in a particular manner. So, that goes into autonomy, where you are working on embedded computer, embedded Linux kind of platform, or it could be a bare metal microcontroller where you are writing bare metal code and achieving the control of the drone. And beyond that, then you will have because finally it is not just about making a drone which flies, we are making a drone for a specific purpose. See, for a disaster response, I may want a drone which could actually fly over a disaster area and scan for people who are there and identify human survivors and go to them and deliver relief material to them directly. Right. So, there I mean you do not know where they are located. Right. So, you have a flooded plain and you are sending your drone 10 kilometers away, and this drone then scans the whole area and identifies survivors and maybe directs other drones to come and give relief material to these people. So, you would have to build some kind of autonomy into it, right. So, I have to put probably a nice camera on board with maybe a small GPU like your Jetson or some other GPU system which could actually do some image recognition and identification algorithms on board and be able to detect with reasonable reliability. Not just detect, but I mean also identify their locations on the GPS coordinate frame and transfer this information to other drones, so that I mean they all can come and do a collective rescue of survivors and help them out with medicines and other essential supplies. So, you can understand, I mean, so that is why I mean we started, I mean people have started calling it as physical AI. So, a lot of I mean intelligence and autonomy has to be brought into these systems to make them more user friendly and more I would say dependable for these kind of environments. Okay. So, these are some of the things which you would be dealing with. I mean we encourage all our students I mean to not just work on the software side of things, but also work with the hardware. So, whatever you will learn you will get to implement. If you design something, yes, we cannot make I mean a HAIL UAV here in IIT Kanpur, but you would be able to probably test some of the ideas maybe in wind tunnel or maybe build some scaled models, fly it and test it out actually. Okay. So, we encourage I mean in the design and aeromechanics also you will get to build things. In the autonomy side also you will get to write codes and test them in real world, and I will give you many examples as we go along the way. Okay. Fine. So, I will just maybe finish after this slide. Okay. Yeah. So, we talked about different types of UAVs. Now, if we focus on the rotary wing UAVs themselves, there are so many varieties in that also. Okay. And rotary wing we normally associate that with your VTOL aerial systems. What is VTOL? VTOL stands for vertical takeoff and landing. So, normal aerial vehicle fixed wing type takes off by using a runway or maybe a catapult or some kind of launcher, which will throw it with a high speed and then it will fly off from there. Rotary wing does not require any of such things. So, these are all vertical takeoff and landing capable, means it can take off from wherever it is standing. So, that is why they are all derivatives of helicopters to be precise. So, you can have a conventional type. So, this is also a drone, this is a twin rotor drone, this is the similar type of drone which was flying on Mars. So, Ingenuity helicopter was of the same kind, coaxial helicopter. So, this is a craft which we had built here in IIT Kanpur, our students have made it almost 13 years back. So, this is a cyclocopter, a new kind of design developed by one of my colleagues. This is the very common popular multicopter. This Hummingbird also could actually do hovering flight. So, all these are actually capable of vertical takeoff and landing, but they also have same problems which a helicopter type platform faces. So, that is why people have now been talking about these hybrid platforms, which means hybrid aerial vehicle means which tries to borrow from both the worlds, fixed wing world and the rotary wing world. So, how can I build a drone which can actually take off and land like a helicopter, but it can fly like an airplane. So, that is actually the hybrid VTOL concept. And so, idea is that, I mean, the fixed wing cannot take off and land vertically, rotary wing has poor endurance, it could be noisy, it would have limited forward flight capability in terms of range. So, why can't we combine the best of both the worlds and build these hybrid UAVs which are efficient in hover and they are capable of high speed, high endurance flight. So, they can go to much farther distance than a normal rotary wing can. And the key problem there is that you should be able to change between the helicopter mode and the airplane mode. So, when you are hovering, you are like a helicopter, and when you are flying forward, you are like an airplane. So, this transition between both the scenarios from takeoff to forward flight and forward flight back to landing has to be very precise and smooth, and that is where, I mean, these crafts are very vulnerable. So, that actually puts challenges for your design of autopilot and also for I mean the design in terms of efficiency itself, how to make these platforms very efficient and very robust, and how to develop autopilots controllers which are also reliable. I will tell you some stories next time also regarding what challenges people typically face in developing such platforms. Okay. So, I will stop here and I will see you on Monday, right. Okay. So, we will see you on Monday. Okay. Any questions before we close quickly? No, fine then, thank you. Okay. So, you should be able to download the first course handout from Pinglai. I have already uploaded it there. Yeah. All right, thank you. Slides I will be uploading it, I mean, either on Hello IITK or I do not know which platform IIT is using right now. So, I will keep uploading them, but so right now this is only introductory part. In future you would want to take notes also. So, whatever you see here, try to take notes. In the first half I will be mostly using PPT presentations, but in the second half of the course I will be doing lot of derivations and board work. Okay. Here also probably I will do some derivations. So, you should also start taking notes, because whatever I say, not everything is there on the slides. So, if you purely rely on slides, it is not very practical. Fine. Yes. All right. Fine.